Hello students, this is a lesson on using the law of cosines. Here's our wonderful trig table. And what's different about this triangle than the ones we've been doing a lot? Yeah, it's not a right triangle. And what information do we have? We have a side length, we have another side length, and we have this angle in between them. So when I see this, my brain is like, oh, I have a side, I have the included angle, and I have another side. So when I see side, angle, side given, I know that I can use the law of cosines. So I have a side, I have the included angle, and I have another side. So my brain sees side, angle, side. And this is actually enough information to know how big this opposite side is. We can also use it to find the angles. So what is the law of cosines? The law of cosines is a formula that relates the cosine of each angle to the side lengths of the triangle. So it looks kind of confusing. This part might look kind of familiar maybe, and then we have this other stuff. So it looks like a kind of complicated formula, but if you plug in things carefully and you take your time, then you can find out the missing sides. So let's try it. So the first thing I'm going to do is I'm going to label my sides. This is going to be side A. Okay, I'm going across the triangle from angle B. I'm going to call that side B. And I'm going to go through the triangle from C. And then 8 is going to be the length of this side. This is angle A right here. Now, there are 3 formulas all as part of the law of sines. I want to find this missing piece. So I'm going to look for the formula that's going to give me this alone on one side. So I'm going to go back and look here. And I want to find A, so I'm going to use this formula. I'm going to be really lazy. And I'm going to copy and paste it. All right, there it is. That's the one I'm going to use because A is missing. This is the side that I'm going to use. Do I know what B is? Do I know what C is? Do I know what 2 times B times C is? Do I know the cosine of angle A? Yeah, I have all that information. So now I'm going to carefully substitute and carefully do my math. I'm going to be neat because mathematicians are precise and accurate. Okay. And all I'm doing is I'm changing the values. B is 10. So I'm going to change this into 10. C is 8. So I'm going to change that into 8. And then I need the cosine of angle A. What's the measure of angle A? 57 degrees. Okay. So A squared equals all of this. Now I can do some of this math. I will. I'll do 100 plus 64 minus, that's 20 times 8, which is 160 times the cosine of 57. And that's 164 minus 160, oops, no, that's 160 times the cosine of 57. I could use my cell phone calculator, or I could be efficient and type that all into here. 100 plus 64 minus, I'm going to be, just to make sure I don't make a mistake, 2 times 10 times 8 times the cosine of 57. 76.85. 76.85. 76.85. Now, that's an approximate answer, right? Because I approximated the cosine of a 57-degree angle. Is this side 70, almost 77 long? That doesn't make any sense. Ah, it's the square of that side. So what I need to do to finish this problem is I need to take the square root of both sides. Okay, the square root of a squared is a. And because it's geometry, we don't have to worry about negative square roots, negative roots, okay? And so I'm gonna go find out what that is. And I think that I can, there's something that says answer. I'm gonna add a new row and then I'm gonna click answer, okay? Now I'm actually gonna delete that. I'm gonna do the square root. I'm gonna do the square root of the answer. And that's the answer. 8.77, I'm gonna round it to. So this missing side, 8.77-ish. I found side BC. If I wanna be consistent, I could change that back to BC. Side BC is about 8.77. One way to check and make sure that you did it right is because see if the like the smallest angle is across from the smallest side. I don't know these angles, so that's not as helpful. But 8.7 is in the same ballpark as 8 and 10, so that's good. All right, let's do it again. Oh no, there's no A, B, and C, so I'm going to decide what's A, what's B, and what's C. I'm going to call this A, because I like, if I'm going to use that law of cosines formula, I'm just going to make A, B, and C. I'll call this B, I will call this C, and I want to find C. And I'm going to use the law of cosines to do that. KL is the same as side C. Okay, so which formula do I need? Right now, I'm going to be looking for the C side. So this time I'm going to try to write it out. C squared is going to equal A squared plus B squared minus 2AB times the cosine of C. That's the formula. Okay, so we're going to do C squared, we don't know, is A squared, that's 9. I'm going to substitute it in. Yes, some of you can do that step, but if you mess it up, then you're not going to have a way to fall back. Always good to substitute using parentheses. Cosine of 90. I'm going to do a little of this math. So 9 times 9 is 81. 4 times 4 is 16. So 40 times 40 is 1600 or 1600. 2 times 9 times 40. 2 times 9 times 40 is 720. And I wonder what the cosine of 90 is. 90 is not an acute angle. If I look on my table, I'm not going to see the cosine of 90. I wonder what the calculator says the cosine of 90 is. Let's try it. So this is a weird kind of thing. Cosine of a 90-degree angle. Huh? Interesting. So what does that mean? What's 720 times 0? 0. What's 81 plus 1600 minus 720? Do you see it? Do you see how all of this goes to 0? So, oh, you go away. I don't want you right now. Okay. So we have C squared is 81 plus 1600 plus 0. Plus 0. Okay. So are you guys seeing, do you see why I chose this problem yet? Anyone? 1681. Okay, what are we gonna do? We're gonna square root both sides. Okay, I'm gonna square root c squared, square root 1681. Square root of c squared is c, and it's geometry class, so we're not worried about the negative square roots. And, oops. Okay, that's that. And I'm going to add a new line, and I'm going to do the square root of the answer. 41. Exactly. That happened to be a perfect square, 41. It's a Pythagorean triple. Did I have to use the law of cosines for this one? Is the law of cosines related to the right triangle theorem? Yeah, this part is the sum of the squares of the sides equals the square of the hypotenuse. So in a right triangle, you don't need this part, or the cosine of 90 is 0. Yeah. I think that's cool. Also, this is the longest side, so that's, excuse me, good, because the longest side always has to be across from the right angle. All right, now how do we do it backwards? So I'm going to mark what we have. We have A is 28. And we have B is, actually, I won't cover that up. Let me try. A is 28. B is 30. C is 32. All right, so what did they give us? They gave us all three sides. They gave us side, side, side. And what we're trying to find is the measure of angle A. So I'm gonna have to figure out how to do this. I can't use law of sines because I don't have an angle and its opposite. It's kind of missing. For law of sines, you need at least one pair of angle and opposite side. So I'm going to use the law of cosines. Let me show you how this works. I want to solve for the measure of angle A, and the only formula that has angle A in it is this one. This is what I want to try to find. So I'm going to use that formula. I have all three sides. I don't have that missing angle. So I'm going to go plug that in. I'm going to use a squared equals b squared plus c squared minus 2bc times the cosine of angle A. If you're trying to memorize the formula, there's, a few tricks. One, A and A, they're on either side of the formula. Also, this part is really related to the Pythagorean theorem, the right triangle theorem. Okay, also, this part you just kind of have to memorize. So I'm going to plug in the numbers. 28 squared is equal to 30 squared plus 32 squared minus 2 times 30 times 32 times the cosine of A, which I don't know. All right, let's go for it. 28 squared. I'm good with my perfect squares up to 15. I haven't put time in to memorize them after that. 28 squared is 784. 784. 30 squared, I can figure that one out. 3 times 3 is 9. So 30 times 30 is 900. 32 squared, I don't know. Just checking myself. Okay, 1024. Two times 30 times 32. 2 times 30 times 32. 1920 times the cosine of A. All right, let's keep at it. Now I'm trying to solve for the cosine of A. So I'm trying to get cosine of A by itself and everything else away from it. So what I'm going to do first is add these together. Try to simplify this as much as I can. I'm going to do 90 and 1024. 90 plus 1024. 1114. All of this is one term. All of this is smushed together by multiplication. Yeah, I'm going to take off 1114 on both sides. And I'm going to do it in the middle here because that's how I'm feeling at the moment. When I do that, this is my zero pair. And this is going to be a negative number. I'm going to do 784. 84 minus 1114. I get negative 330. And then I get negative 19. See, this negative sign is still here because it was in front of the 1920 here, cosine A. The good thing about this is I'm going to divide both sides by negative 1920. And that what's good about that is that a negative divided by a negative is a positive. So this is going to be some little teeny tiny decimal. This is 1. So this is 1 times the cosine of A, which is cosine A. And let's figure out what this little decimal is. So 330 divided by 1920. Negative 330 divided by negative 1920. Negative divided by a negative is a positive. It's this little decimal. So that's all good. How am I going to figure out what the angle measure is? I have a choice. I can go look in the cosine row for this little digit decimal, and that will tell me the angle. Or I can use the inverse cosine. Inverse cosine is going to tell me it's an 80.1 degree angle. That's pretty cool. So let's go back a step and find out what that decimal is. 0.1719. 0.1719. Okay, and then the last step, which I don't have a lot of room for, I'll squeeze it in right here, was to do the inverse cosine of both sides. Oh, I missed this. Okay. The inverse cosine of the cosine of A is just the measure of angle A. And the answer was 80.1. All right, I did it. That's about an 80.1 degree angle. Take some algebra. Do the same thing on both sides. Okay, divide the same thing on both sides. And then stick with it. Follow it all the way through. All right, last one, I think. No, there's 2 more. I'll do both of them. This is fun for me. Let's call this B. We'll call this A. And we'll call this C. I want to find B. So the formula is B squared. That's what I'm trying to find. Is A squared plus C squared minus 2AC times the cosine of B. So B squared is what I'm trying to find out. That's 6 squared. This is 8 squared. This is 2 times 6 times 8 times the cosine of 62. So B squared is, I'm going to be really lazy and type all this in. 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 62. Let's go back to main. Already forgot. 6 squared plus 8 squared. 6 squared plus 8 squared minus 2 times 8. Oops, 2 times 6 times 8 times the cosine of a 62-degree angle. All right, it's about 54.93. .93. How do I finish it? Square root both sides. Because 54 is not a reasonable answer. Square root both sides. And that will be my approximate answer for how big B is. Notice I had this side, the angle included, and then the other side. That's a really good clue that you're supposed to use the law of cosines. All right, and then let's finish that. Yeah, I could. Oh, delete. I could just put a square root on the front of the whole thing. How do I undo? Aha. Let's see if I can do it. Can't figure it out. Okay, so another way to deal with this is to add a new line and then the square root of your answer from above, and that gives you 7.41. Maybe we'll round it to 7.41. That makes sense. Square root of 49 is 7. This is bigger than the square root of 49. There we go. Done. If I wanted, I could say this is side DE. DE is about 7.41. Okay, last one. Let's call it C again. And we'll call this A. We'll call this B. Okay, and I'm trying to find that missing side length, which was GH, and now it's AB. And it's C squared equals A squared plus B squared minus 2AB times the cosine of C. C squared equals 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of 110-degree angle. Also not going to be on our table, right? Okay, but it is on a calculator. We don't have 110-degree angles in right triangles. We haven't seen a 110-degree angle in a long time. So I'm so efficient. Look how efficient I am. It was a 12 and an 18. Watch. 12, 18. Whoa, you guys, it's remembering it from up there. Oh, that's kind of cool. Cosine 110, yeah? It did all the math for me. I didn't have to do anything. Because calculators are cool like that. All right, 24.8 is my answer. 615.7 and then 8. And it was 615-ish. And then square root both sides. I'm just going to put some decimals here. And then I get C. And it told me it's about 24.8. Was it reasonable? Yeah, that angle is pretty wide open, so looks good to me. I may have made a mistake. If someone sees it and catches it, you can put it in the comment section. All right, be good, keep learning, work hard. Bye.